Mr. Ko here, and today's topic is the Pythagorean Theorem, and our goal for today is we're going to apply the Pythagorean Theorem to solve for a missing length. And our California standards for today is Measurement and Geometry 3.3. So first of all, our main thing that we need to know here is, of course, the Pythagorean Theorem. And here we have a right triangle, and again, Pythagorean Theorem is mostly about right triangles, and we need to know this particular formula, which is a squared plus b squared is equal to c squared. Okay? And that again means a times a plus b times b is equal to c times c. So make sure you copy this part down. Quite important. Alright, so let's go ahead and go over our first steps. And again, it's done in a thinking map flowchart style. So we're going to first of all label A, B, and C. Then we're going to substitute for A, B, and C. We're going to isolate for A, B, or C, and then we're going to go ahead and square both sides and simplify. And I'm going to go ahead and talk through this while I'm going through this particular equation as well. So the first thing we're going to do here is we're going to label. So let's start off with A and B, and that's your C. And don't forget, your C is always your longest side of the triangle. That's normally what is called your hypotenuse, your longest side of your triangle. And the other two are your sides, and they're always going to be smaller than your longest side for a right triangle. So this would be A, and this would be B. And normally, you could probably call them legs. That's another way to go and talk about the sides. In this case, I'm just going to call them A and B in this part. Okay. So first off, we're going to go ahead and label A, B, C, and again, our longest side. We're now going to substitute. So 5 is going to be right here, so that's A. And again, these two, when you add them and you do all that crazy changes, you can't interchange them. You could call this A and you could call this B. Okay? So don't forget your exponent. Here you're going to have plus 12. And don't forget that power again is equal to c squared. And notice that we don't have anything for c because that's what we're trying to find out. So here, 5 to the second power does not mean 10. It means 5 times 5, which is 25. Plus, and 12 times 12 is 144, is equal to c squared. So now we've substituted. Now we're going to solve. And when we solve, that becomes 169, which isolated our variable. So notice that c squared is equal to 169. Now, this is the really tricky part. We're going to go ahead and find the square roots for both of them, because when we find the square roots for both of them, that gives me c. Because the square root of c to the second power is c, which is what we're looking for, and we need to square root this. So the square root of 169 is going to give us 13. And that's it. Alright, now let's go ahead and do one where we're solving for one of the legs of the triangle, or the sides of the triangle, and not the c, or not the hypotenuse part. So first of all, number one, we're going to label. So A, B, C. Once we're done labeling, we're going to substitute, put the 9 in here. Our B, we don't know what that is, so we're going to go ahead and leave it. And then that's 15. And don't forget that the exponent of 2. So now that's 9 to the second power, which is going to be 81, plus b squared. 15 to the second power is going to give us 225. Now this part here, we're going to isolate for what we're trying to solve, which means we want b to the second power on one side, and then the other part is going to just be the answer. So in order to do that, we're going to go ahead and subtract this by 81, and according to the property of equality, subtract 81 here. I now have b squared is equal to, and that's going to give me 4, and that's going to be 12 minus 8 is going to give me 4. We had to borrow, that's 1, so that's 144. And now again, we've come across to a b squared. In the other one it was c squared, but this one we're now looking for a side of the triangle. So it's b squared is equal to 144. And so we're now onto this step where we're going to go ahead and square root both sides. Okay? Squaring this gives me b, and then squaring that gives me 12. And that's our answer for this particular one. Alright, so now, these came out really nicely. They had nice whole numbers as answers. So what happens when you're not going to get a nice whole number as an answer? Well, then you're going to have to kind of guesstimate what that answer is going to be, because it's going to be a square root of a number that is not perfect. Okay? So first of all, same thing, label A, B, C. So let's go ahead and insert and substitute. So we're going to go ahead and substitute this for 6 squared plus b squared, since we don't have a b, and that's going to give us 11 squared. So continue on, that gives us 36, plus b squared is equal to 121. And just like what we did on the previous one, we're going to go ahead and subtract 36, and then continue on. We now have b squared is equal to, and that's 11 minus 6 is going to give us 5, 11 minus 3 is going to give us 8, and then of course we had borrowed from here. Okay, so now we have the same step again, and then of course we're going to go ahead and square root this. The only difference between this one and the other couple of previous ones that we've done is that we've always had a nice number here, and that nice number is a perfect number, which means our answer comes out to a nice square to a nice square root. In this case here, we don't have that. We have square root of 85. Now this is going to give us b. We're still looking for this one. Now we're going to have an approximation now. If you look at it, square root of 85, we need to look for the number that it is closest to, the perfect square root that it is closest to. And if you think about it, if I take 9 times 9, that gives me 81, which means my number is going to be 9 something. If I choose 10, 10 times 10, that's way too big for that, it's 100, so which means I know that my answer is going to be 9. And now I'm going to have to figure out what that decimal is. So if I look at this, and I'm thinking, well, 85 is only about 4 away from 81, which means it has to be more on the lower side, because 10 times 10 is 100, and that's about 15 more on that side. So if you kind of look at it, you're looking more at like 9.1, 9.2. So let's go ahead and just call this about 9. Let's go and just bump it up to about 9.2, okay? And so we can't use an equal sign anymore, so we're going to just change it to an about. So our answer for the square root of 85 is about 9.2, okay? Alright, now let's go with the very final problem, which is a word problem, and you will see the ladder problem everywhere. It's on your test. It is definitely on the CSTs, so make sure that you understand what they're asking you to do. So what I normally do here is I just draw. So here we have a ladder. It's placed 9 feet away from the building. So I'm going to go draw the building, and I have a ladder, and this ladder is propped up against the building. Okay, and the ladder here is 9 feet away. So from here to here is 9 feet. So if you look at it, that looks very much like a triangle. And here, if you look at it, and it touches the building at 15 feet from the ground. So from the ground, it touches it from here. From the ground up, it's going to touch right here, and from here to here, this is 15. Okay, so what are we trying to find out here? Well, we're trying to find out what is the length of the ladder. So the ladder length is what we don't know. So that's what we're trying to find out. So let's do the same thing again. We're going to label. So we're going to find out what we need to know, which is our A's, B's, and C's. So let's look at this. We have a triangle here. If you look at it, don't mind the building part. But the way that it's shaped, it's a building. It's a triangle. So we're going to say this is A, this is B, because our ladder is actually our C, because that's the longest length of this particular thing. Okay? So we now have our A, B, and C. Then basically we can just solve it out. So our A is 15 squared. Our B is 9 squared. And then our C is C squared, which is what we're trying to find out. So that's going to give me 225. That's going to give me 81. And that's going to give me C squared. I get to add this together to isolate that. So that's going to give me 6, 0, and if I put 1 over, you're looking at 3, 1. Let's see. 11. 06. That looks about right. Alright. And now you're back at this part again. Once you see this, we want to make this into C. So all we're really going to have to do here is just square root. Okay? And that's about it. You can square root that. and then that's going to give me c, and then now I have to figure out what times itself is going to give me close to 306. I know that 15 times 15 is going to give me 225. Let's try 16 times 16. So if I take 16 times 16, that's going to give me 6, 3, 96, 6, 1. So you're looking at 6, 5, 1, 256 for 16 times 16. That's pretty close, but let's try another one. Let's try 17. So if I take 17 times 17, I get 9, 4 there, that's going to be 11, 7, that's 1. That's going to give me 9, 8, 2. Much closer. I'm pretty sure the 17 is probably going to work for me, but let's try one more just in case. So let's do 18. That's going to give me 4, 6, that's 144. Then it's 8, and then 1. So you're looking at 4, 2, 324. So that's too big. But, so basically our number is going to fall between 17 and 18. So let's look at it. So we have 17. Now, compared where this number is and comparing where this number is, let's look at 306. Isn't 306 about, let me see, 11 to here, that's looking at 17? And then from here to here, you're looking at, it looks like 18. Oh, this is a perfect one. So to go from this to the next number up, you're looking at halfway. To go from this to this, you're looking at halfway, which means your answer is roughly about 17.5. All right? Alright, if you'd like to see more videos, go to www.youtube.com/user/psychodad, and that's it. Have a great day.